This video is over the composition of functions. So the composition, the notation for it is f of g of x, or right here that looks like fog of x. The proper way to read it is f composed with g of x. So example 1, we have 4 parts 2. We have f of x equals x squared minus 5x plus 2, and g of x equals a negative 4. So in part A, we want to find f composed with g of 2 instead of x. So a couple different things we can do with this one. First, we could always rewrite it into this form right here. I think that one's a little friendlier to use. So I'm going to rewrite it. So f of g of 2. Okay. If you look at the insidemost part, we have g of 2, which we can go ahead and solve for. So what that means is we're going to take 2 and we're going to plug it into the g equation. So I'm going to find g of 2, which means I have negative 4 times 2, which turns out to be a negative 8. So if I rewrite this, it'd be f of negative 8. All I did was I replaced that g of 2 with what g of 2 equaled, which was negative 8. So now I'm going to plug that into the f equation. So I have f of negative 8 equals negative 8 squared minus 5 times negative 8 plus 2. Well, negative 8 squared is a positive 64. Negative 5 times negative 8 is a positive 40 plus 2. When I add 64 plus 40 plus 2, I get 106. So this right here would be f, or fog of g of not x. We didn't plug in x. We plugged in 2, so f composed with g of 2. So we get that right there. Letter B, we just have the order switch, so let's see how that does. So we're going to start by finding f of 2. So f of 2 is 2 squared minus 5 times 2 plus 2. So 2 squared is 4. Negative 5 times 2 is a negative 10 plus 2. When I do that, negative 4 minus 10 plus 2, that gives me a negative 4. Then I replace f of 2 with a negative 4 because that's what it equals. So now I'm going to find g of negative 4. So I just take the output I get of f of 2 and I plug that into g of 2. So I have negative 4 times negative 4, which turns out to be a positive 16. So this is g of f of 2. If we notice, when I switch the order, I do get a different outcome. So compositions are not commutative in these cases. Looking at letter C, I have f of g of negative 3, so I'm going to start by finding g of negative 3, so I'm plugging in negative 3 for g. So g of negative 3, that gives me a negative 4 times a negative 3, which turns out to be a positive 12. I take that output and I plug it into f, so I want to find f of 12, which means I have 12 squared minus 5 times 12 plus 2. Well, 12 squared is 144. Negative 5 times 12 is a negative 60 plus 2. When I add all three numbers together, 144 minus 60 plus 2, I get 86. So f of g of negative 3 equals 86. Okay. Letter D, it looks like golf. G composed with f of negative 3. Again, I can always rewrite it. Oops, it's trying to talk to me on this video. So I'm going to rewrite it. Let me fix my handwriting. So I have g of f of negative 3. So I'm going to start by plugging in negative 3 into f first. So I'm going to find f of negative 3. That gives me negative 3 squared minus 5 times a negative 3 plus 2. Negative 3 squared is 9. Negative 5 times a negative 3 is a positive 15 plus 2. When I add all three of those numbers together, I get a positive 26. I take that output and I plug it into G. So I'm going to find G of 26. So I get negative 4 times 26. Negative 4 times 26 is negative 104. So this would be G composed with F of negative 3. Again, showing that composition is not commutative, meaning when we switch the order, we get two different outputs. Now, looking at example 2, I have f of x equals a negative 3 and g of x equals x squared. And also, if you notice on these, I'm no longer plugging in a number for them. I'm leaving it as x. So that means I'm taking a whole equation and I'm going to end up substituting it in rather than just a number. So first off, I'm going to start by rewriting this to the other form because I do think the other form is a little friendlier to work with. So I have f composed with g of x, or f of g of x. Well, we all know what g of x equals. G of x equals this x squared. So I'm going to replace that g of x with x squared. So what this tells me is anywhere I see an x in the f of x equation, I'm replacing it with an x squared. So what that looks like would be, I have x minus 3, so it turns out to be x squared minus 3, and that would be it for that one. Okay, looking at letter B, again, I'm going to rewrite it into the friendlier form. Okay, f of x equals x minus 3. So I'm going to go ahead and rewrite that. And anywhere I see an x in g of x, I'm replacing it with x minus 3. So g of x minus 3, what that looks like is I have x minus 3 squared because it was x squared, and we replace the x with g minus 3. Now I do want to go ahead and expand that by multiplying. So what that means is I have x minus 3 times x minus 3, like that. I use the area model to do that, so that's the box. I like it better than FOIL just so I know I don't miss any steps. So x squared, or x times x is x squared, x times a negative 3 is a negative 3x, negative 3 times x is a negative 3x, and negative 3 times negative 3 is a positive 9. So this turns out to be x squared minus 6x, combining the like terms, plus 9. And this is g composed with f of x. Again, showing once again that composition is not commutative. If you need more videos on this, there will be a part on the inverse videos that has more compositions with it. So be sure to check that out.